A beekeeper is starting a new colony of bees. The population B of bees in thousands is given by B of T is 4e to the 1.4t, where t is the number of years since the establishment of the colony. Determine the initial population of the colony. Well, the initial population will be when t is equal to 0. So b of 0 is 4e to the 0, which is equal to 4. Now remember, that's in thousands, so it's going to be 4,000 bees. Determine the increase in the population of the bee colony in the first 6 months. So t is in years. 6 months would be half a year, so 0.5. So we want b of 0.5, which is going to be 4e to the 1.4 times 0.5, and we just need to calculate that. So let's bring in the class pad. Let's just clear anything I've got there. And we are going to calculate 4 times e to the 0.7. And that is going to give me 8.055. So our increase in population is going to be 8,055. Take away 4,000 is 4,055 bees. Determine the rate of population growth 2 years after the establishment of the colony. So rate of growth, we're now talking about dB dt. And since b is 4e to the 1.4t, dB dt is going to be 4e to the 1.4t multiplied by the differential of the inside function, which is 1.4. So that is going to give me 5.6 e to the 1.4t. 2 years is t equals 2. So it's going to be, so with dB dt when t equals 2 is going to be 5.6 e to the 1.4 times 2. And we can calculate that. So we have 5.6 times e to the 2.8, which is 92.09, which is, remember this is in thousands, 92,090 bees per year. After how many years will the rate of population growth be 65,000 bees per year? So our expression for the rate of growth is 5.6 e to the 1.4t. And so we want that to be equal to 65. Remember, it's in thousands, so we just need to change that to 65. And then we can just solve for that. So solve, let's just grab that, bring it here and just edit this bit to be 1.4t or 1.4x, and then just put that equal to 65, and that is 1.75. After 3 years, the beekeeper notices that the number of bees begins to decline. The declining population, small b in thousands, has the form Bt is equal to Ae to the Rt, where T is the number of years since the start of the decline. Determine A and R if 1 year after the start of the decline, the bee population is 100,000. I think the first thing we need to know here is the population after 3 years. So that's going to be B of 3, which is 4e to the 1.4 times 3. So let's calculate that first. And I can probably just go back up here and just edit that into 1.4 times 3. And that gives me 266.7. 0.75, say. Actually, stick with the 745 because we're going to multiply by 1,000, aren't we? And so that means there would be 266,745 bees. So if now small b of T is equal to Ae to the Rt, we know that B of 0 is going to be 266.745, which is equal to A. So that's because T equals 0, and this part of the formula is just going to be 1. And then we know that B of 1 is equal to 100. And that's 100,000 there. And that's going to be equal to 266.745 e to the r. Remember, t is equal to 1. And we can solve for that. So we'll use solve. And we've got 100 equals 266.745 e to the x, and execute there, and it's negative 0.981.